Supreetha. Welcome to my math class. In the previous lectures on Laplace transform, we studied some direct formulas. Yes, we studied the relation between Laplace and inverse. Okay, it is just a flip, right? And then in the previous lecture, we studied something about shifting property for inverse Laplace transform. Yes. So in this video lecture, let me solve some more problems on inverse Laplace transform. Yes, our first question is, find the inverse Laplace transform of 1 divided by s into s plus 1 into s plus 2. Okay, how do we solve this? If I had something like 1 plus, if I had a positive sign between three terms, that is if I had something like 1 by s plus 1, positive or negative, anything, I would have applied some of our formulas, direct formulas. But here we have three terms in product. So what I'll do is, I will bring in the concept of partial fractions. What do we do in partial fractions? If we have fraction and product, yes, see, in the LHS, every term we have it in product. Yes, but in the RHS, after applying partial fractions, that gets splitted. Yes, we get a divided by x minus a, b divided by x minus a. In the middle, we would have plus or minus in our problem. Okay, so this is exactly what we need for our problem right now. Yes, observe now. Our problem is 1 divided by s into s plus 1 into s plus 2. I can write s as s plus 0. So we have three terms. Yes, it is in our this format. Okay, so this I can write it as a divided by x minus a, correct? So what I'll do is, I'll write our given inverse Laplace transform question as LHS would remain as it is, s into s plus 1 into s plus 2. This is equal to a divided by s plus b divided by s plus 1 plus c divided by s plus 2. Okay. Now what should I do? I should take LCM in the RHS. What would that be? S into s plus 1 into s plus 2. In the numerator, I would have the terms other than s. That is s plus 1 into s plus 2 plus b into the terms other than s plus 1. That is s into s plus 2. This is how we take LCM, right? Plus c into terms other than s plus 2. That is s into s plus 1. And the LHS remains as it is. Okay. See, the denominator terms are same, so it gets cancelled. 1 is equal to, I write this term as it is. So yes, this is what is left, right? The denominator got cancelled. Now I would have to find ABC values. For finding ABC values, there are two methods. One, equating the coefficients. Okay, equate the coefficients of clearly s square. You would get s and constants. That is one method. Okay, I will use another method, that is, I will give some values for s. Say, I'll give, say, let s is equal to minus 1. Why am I giving minus 1? Because when I give minus 1, see, let me substitute s as minus 1. I would get minus 1 plus 1. So a goes away. This is 0, right? 0 into anything is 0. Plus b into minus 1 into minus 1 plus 2 plus cs into, even here it is minus 1 plus 1. Even this term goes away, it becomes 0. I would get b value. That is why I took s is equal to minus 1. So that would be 1 is equal to minus b. 2 minus 1 is 1, right? So our b value is minus 1. Okay. Now let me take, say, let s is equal to minus 2. What will I get? In this equation 1, now equation 1 becomes LHS will remain as it is just because there is no S term in the LHS. Okay. So 1 is equal to A into minus 2 plus 1 into minus 2 plus 2. So this becomes 0 plus B into minus 2 into minus 2 plus 2. Even this term becomes 0 now because minus 2 plus 2, right? Plus C into minus 2 into minus 2 plus 1. So we would get now our C value. Therefore, 1 is equal to, this term is 0, even this term is 0 because minus 2 plus 2, even here I have minus 2 plus 2, that was my goal. My goal was to find C. Okay, so here I have minus 2. Here I would get minus 2 plus 1 is minus 1. Yes, so what is minus 2 into minus 1? It is plus 2 and C would remain as it is. So value of C is 1 divided by 2. Yes, I substituted S as minus 1. I took S as minus 2. Now check for which value of S would you get the value of A. Yes, let S is equal to, say I'll give 0 now. Okay, why? I have S here, I have S here, 0 into anything is 0. But here I have S plus something, correct? So I would get 1 is equal to A into 0 plus 1, which is 1, into 0 plus 2, which is 2, plus B into 0, 0, plus C into 0, 0. So now I would get A value, which is half. Okay, now we found our ABC values. Okay, call this as equation A now. What is our next step? Substitute ABC values in equation A. Okay, write down one line. Say substituting ABC values in equation A. Okay, so what is A value? A value is half divided by S plus, what is B value? Minus 1 divided by S plus 1. C value is half divided by S plus 2. Yes, now what should we do? We should find inverse Laplace transform of this, right? I just did a little bit of changes, that is I applied partial fraction concept to our question so that I would get 3 terms like this in addition or subtraction. When I have like this, it would be easy for me to find the Laplace inverse, correct? 2 into S plus 2. Now what should I do? I'll apply Laplace inverse. In the LHS, what did I have? I had S into S plus 1 into S plus 2, right? From equation A, S into S plus 1 into S plus 2. Now, what is my Laplace inverse? Can I give Laplace inverse for each term? Here half is a constant. So 1 by S minus Laplace inverse of 1 divided by S plus 1 plus half is a constant again, Laplace inverse of 1 divided by S plus 2. Yes, so I have half. What is Laplace inverse of 1 by S? What is the formula? Laplace inverse of 1 divided by S is equal to 1. Okay, what is Laplace inverse of 1 divided by S minus A? S minus A is e power at. So if I have S plus A, it would be e power minus at. Okay, so what would I write over here? I'll write Laplace inverse of 1 by s is 1 itself minus Laplace inverse of 1 divided by s plus 1 is e power minus 1 into t, which is e power minus t, plus half is a constant. Laplace inverse of 1 divided by s plus 2 is what? E power minus 2t, using this formula. Yes, so clearly Laplace inverse of, we have found Laplace inverse of our given question. Okay, moving on to our next question, that is, yes, find the inverse Laplace transform of 4s divided by s plus 1 whole square divided by s plus 2 whole square. Now, compare the formulas. In which form is our given question? We have something like a polynomial in the numerator. Yes, it is this formula. Agree? We have something square, right? In a bracket we have s plus 1 the whole square into s plus 2 the whole square. Okay, so we would have to write it as a divided by s plus 1 plus b divided by s plus 1 whole square plus c divided by s plus 2. Yes, so let me write it in that form. It would be, yes, that would be the given question, 4s plus 5 divided by s plus 1 the whole square into s plus 2. This is equal to a divided by s plus 1 plus b divided by, okay, b divided by s plus 1 the whole square plus c divided by s plus 2. Yes, what is the next step after writing it in this form? Take LCM. How do you take LCM? The denominator would be s plus 1 whole square into s plus 2. Yes, so here I would have a into, I already have one s plus 1. So I'll write another s plus 1 into s plus 2 plus b into s plus 1 whole square is already there. So I'll write it as s plus 2 plus c into s plus 2 is here. So I'll write s plus 1 the whole square. What do I have in the LHS? I have 4s plus 5 divided by s plus 1 the whole square into s plus 2. The denominator terms are same, so it gets cancelled. Yes, so what else I have? 4s plus 5 is equal to a into s plus 1 into s plus 2 plus b into s plus 2 plus c into s plus 1 the whole square. What is the next step? I would have to find ABC values, correct? How do I start? Let me take, say, s is equal to minus 1. If I take s is equal to minus 1, a would become 0, c would become 0. I would get b term, correct? So what I should do is 4 into minus 1 plus 5. This is equal to a into minus 1 plus 1. This would become 0 plus b into minus 1 plus 2. Okay, plus c into the same thing, minus 1 plus 1 the whole square into c. This becomes 0, correct? This and this term becomes 0. So I would get minus 4 plus 5. This is equal to b because 2 minus 1 is b, right? So what is our b value? B value is 1. What is the next step? I would have to find a value. Okay, for finding a value, what can I take s value as? I cannot take it as minus 2. Agree? So if I take 0, even that wouldn't help. So what I'll do is, I'll simplify the equation. Okay, I'll try finding other a and c values by equating the coefficient methods. Okay, so this would be a into s square plus 2s plus 1s, right? So that would be 3s plus 2 plus bs plus b into 2 plus c into a plus b whole square. S square plus 2s plus 1. Okay, what I'll do is I'll equate coefficients, okay, of, let me equate the coefficient of, I need the value of a, right? Say s square. If I equate coefficient of s square, in LHS I don't have s square, so LHS would be 0. In RHS, coefficient of s square is what? A plus coefficient of s square here is c. I'll take this as, say, equation A because I don't know A and C values. Correct? Now, what would be coefficients of S? On the LHS we have 4. In the RHS I have 3A, right? So this is S. A into 3 is 3A. Okay? Plus B here, we have B here. Okay? Plus 2 into C. Okay? Let me take this as equation B now. What is the final thing? Let me equate coefficient of constants. What would I get? 5 is equal to 2a, okay, 2a plus 2b plus c. Yes, so now I would have to simplify these equations. Okay, firstly in equation B, let me substitute B value. We already know B value, right? So let me substitute that over here. Okay, so what would I get? I would get 4 is equal to, yes, 4 is equal to 3a plus 1 plus 2c. So I would get, if 1 comes to this side, it will become 3 is equal to 3a plus 2c. Let me take this as equation B. Okay, even in this equation, I will substitute the value of B. I would get 5 is equal to 2a plus 2 plus c. If I send 2 to the other side, that would become 3 is equal to 2a plus c. This is our equation C. Now, we have equations A, B and C. Take any two equations and simplify. It is your wish. Okay, you would get same terms. Let me take equation A. In equation A, what I'll do first, I'll multiply 2 here. Yes, what would I get then? I would get 2a plus 2c is equal to 0. This is our equation A into 2. Okay, what is our equation C? Our equation C is 2a, yes, 2a plus c is equal to 3. Correct? Now if I subtract these two equations, say I subtract these two equations, 2a gets cancelled, I would get c is equal to minus 3. Okay? What next? I'll substitute this c is equal to minus 3 in any one of the equations. Okay, let me take equation A itself. What was equation A? I can either take 2a plus 2c is equal to 0 or I'll just take a plus c is equal to 0. Yes, a value is plus 3, right? Substitute in place of a minus 3, it goes on the other side, you will get plus 3. So we have our a, b, c values. Yes, what I'll do next? I'll substitute, yes, substituting, okay, a value is 3, b value is 1, c value is minus 3, In which equation? Let me zoom out. In equation number 1. Okay. So what is our equation 1? See, our equation 1 is, okay, let me name this as equation start. We would have to substitute it over here. Okay, so here let me make this as star. Okay, so now what do we have our equation 1? That is 4s plus 5, our given question. 4s plus 5 divided by s plus 1 the whole square into, what do I have? S plus 2, is it? Yes. S plus 2. This is equal to a divided by, so 3 divided by s plus 1 plus b divided by, so that would be b divided by s plus 1 the whole square. Okay. Plus c divided by, what is our c value? It is minus 3 divided by s plus 2. Yes. Now what is the next step after partial fractions? We would have to find Laplace inverse. Okay. Let me write down Laplace inverse of 4s divided, okay, 4s plus 5 divided by s plus 1. Okay. S plus 1 the whole square into s plus 2 is equal to Laplace inverse of, 3 is a constant, I'll write it out. 1 divided by s plus 1 plus Laplace inverse of 1 divided by s plus 1 the whole square minus, 3 is a constant, Laplace inverse of 1 divided by s plus 2. Yes, for the first term and the last term we have a direct formula. What is that formula? Laplace inverse of 1 divided by s plus a is equal to e power minus at. So this would be e power minus t. This would be e power minus 2t. How about the second one? We don't have any direct formulas. Correct? What should we do for this now? We would have to apply shifting property. Yes, what was our shifting property? Laplace inverse of 1 divided by s plus 1 the whole square. Okay, for shifting property, what should I do? Yes, apply. Observe if you have a bracket in the denominator. Since we have 1 in the numerator, we can just leave it as it is. Okay, what is the first step? I'll replace s minus a with s, right? So I'll replace s plus a with s. So I would get Laplace inverse of 1 divided by s square into e power, see, s plus 1 with s, right? Okay, this is s minus a. Okay. This is s minus a with s. So in place of a, what do I have? I have minus t. Okay, what was the next step? Applying Laplace inverse for this f of s, right? Our f of s. What is Laplace inverse of f of s? What is the formula? The formula that we use is Laplace inverse of 1 divided by s to the power 1 plus 1, or n plus 1 is equal to t power n divided by n factorial. So this would be, I can write this n as what? I'll write it as 1 plus 1. So in place of n I have 1. Correct? So this is equal to t power n, that is t power 1 divided by 1 factorial into e power minus t. Yes, so what would happen to our Laplace inverse, our main question? That is Laplace inverse of 4s plus 5 divided by s plus 1 the whole square into s plus 2 This is equal to 3 will remain as it is. As I told you, I can write this as e power minus t plus Laplace inverse of 1 divided by s plus 1 whole square is t e power minus t minus 3 into e to the power minus 2t. Okay. So yes, moving on to our next question, that is, yes, find the Laplace inverse of or inverse Laplace transform of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. Okay, what is the first step? Compare this with the standard formula of partial fractions. Yes, in which form is it? Our given question is 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. Observe, in which form is it? It is in the last form. Agree? Clearly you have s. In place of x minus a, I have s minus a. In place of x square plus bx plus c, I have s square plus 2s plus 5. Okay, so how should I write this problem as? I would have to write it as something like this. Let me copy this. Okay, the formula is I would have to write it in this format. Okay, so what do I have in place of x minus a? Yes, so let me write down the given question itself once. That is 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. This is equal to a divided by x minus a. I should write it as a divided by s minus 1, right? Plus b. In our problem, we don't have x, correct? We have s. So bs plus c divided by whatever polynomial you have, that is s square plus 2s plus 5. Okay, after writing it in this form, what is the next step in all the problems? Take LCM. Okay, LCM would be what? S minus 1 into s square plus 2s plus 5. So here I already have s minus 1. So I'll write s square plus 2s plus 5 plus bs plus c. I'll write it as it is into s minus 1. Okay, so in the LHS, what do we have? Divided by s minus 1 into s square plus 2s plus 5. So the denominators are same. I'll divide them. Sorry, I'll cancel them or divide them. Okay. So we have what? 5s plus 3. This is equal to a into s square. Correct? A into s square plus 2s plus 5 plus bs. Correct? Bs plus c into s minus 1. Okay, let me give a value for s now. I should find a, b, c values, right? For that, I'll give, say, let a is equal to or let s is equal to 1. Why? Here, if I give one value, 1 minus 1 would become 0 and I would get a value. Correct? So LHS becomes 5 into 1 plus 3. This is equal to a into 1 square plus 2 into 1 plus 5 plus 0. Okay, so here I would have 8 is equal to 8a. So our value of a is 1. Okay, now we cannot give any other s values, right? If we give it as 0, we will still have b, c, a, b, c. We would get a equation in the form of a, b and c, correct? What if I give, say, let s is equal to 0. Okay, I'll give s value as 0. Let me see what will I get. Yes, say s value is 0. I'm taking this. Okay, let s is equal to 0. What happens in the LHS? 5 into 0 plus 3, right? So that would be 3 itself. This is equal to a into 0 square, 0 plus 2 into 0, that would be 0 plus 5. So whichever term doesn't have 5 with it, I'll just write that term. Clearly, B has a S with it. Whichever term doesn't have S with it, right? So, C into this would become 0 minus 1. That would be minus 1. Okay. So, let me substitute A value. What is A value? 1, right? So, 5 into 1 minus C. Yes. What happens if I send this 5 to the other side? It will become 3 minus 5 is equal to minus C. So what is our C value? It is positive 2. We now know what is A value, what is C value. What should we find? We should find B value. Okay, for that what I'll do? I'll substitute or I'll equate the coefficients. Okay, here I would get, yes, here what is BS into S square? So I would get BS square, right? BS into S would be BS square. Okay, why did I do that? I'll just equate the coefficients of S square. Yes, on equating, okay, on equating coefficients, okay, coefficients of S square. In LHS I don't have S, so sorry, in LHS I don't have S square, so that would be 0. This is equal to, in the RHS, the coefficient of S square in the first term is A, right? So I would get A plus, as I told you, here I would have only one S square, and the coefficient of that S square is B. So I would have plus B. Okay, what is the value of A? The value of A is 1. So I would get 0 is equal to 1 plus B. So our value of B is minus 1. So now we have our ABC values. What should I do? I should substitute these ABC values in our equation 1. Okay, let me do that. What would I get? 5s divided by, let me just copy this to be easier for me to solve. Yes. So this was our equation. In place of A, I'll substitute what? 1, right? So this was our, say, equation 1. So RHS would become what? In place of A, I'll substitute 1 minus 1 plus, in place of B, I would have to substitute minus 1. So I would get minus S plus 2 divided by S square plus 2S plus 5. Okay, so you see the first term, it is easy. We know what is Laplace inverse of 1 divided by S minus 1. Let me write down one step. Laplace inverse of, yes, Laplace inverse of 5S plus 3 divided by S minus 1 into S square plus 2S plus 5. This is equal to Laplace inverse of 1 divided by s minus 1. I'll give the Laplace inverse for each term. Yes, plus, can I write minus s plus 2 as 2 minus s divided by, okay, I would have to write this as Laplace inverse of, right? I'll write it as Laplace inverse of 2 minus s divided by s square plus 2s plus 5. Okay. Now we know what is Laplace inverse of 1 divided by s minus a. Laplace inverse of 1 divided by s minus a is what? E to the power, yes, e to the power at. Yes, so the first term, the Laplace inverse of 1 divided by s minus 1 would be e power t itself. Okay, for finding Laplace inverse of the second term, that is Laplace inverse of 2 minus s divided by s square plus 2s plus 5, I would have to use shifting property of inverse Laplace transform. What was shifting property of inverse Laplace transform? Let me first observe if there are any brackets in the denominator. We don't have any, so let me try bringing one. See, I have a square. Okay, in place of a I have s. So this would be my 2. The formula is 2ab, right? So this is my a. So let me write into 1. So this would be my b. So what do I want? I want a square plus 2a into 1 plus 1 square. Correct? So this would be my a square plus 2ab plus b square. So what I'll do is, this is equal to 2 minus s divided by s square plus 2s plus 1. I'll write this as plus 4. Okay, so this is equal to what? 2 minus sy. 1 plus 4 is 5 itself. Okay, divided by s plus 1 the whole square. Plus 4 remains as it is. Okay, now what do I have in the denominator? I have a bracket. Let me get this same bracket term in the numerator. What should I do for that? I have 2 minus s. I'll subtract 1. I'll add 1. Divided by s plus 1 whole square plus 4. So what would I get? 2 minus common s plus 1, okay, plus 1 divided by s plus 1 the whole square plus 4. What is our next step? I would have to replace s plus 1 with what? With s. Okay, so let me add this 2 plus 1. That would become 3 minus s plus 1 is what now? S divided by s square plus 4 into e to the power minus t. Why? Compare. We are replacing s minus a with s, right? In place of a, I have minus 1. Okay, what should we do now? This is our f of s. We should find Laplace inverse of f of s. That is 3 minus s divided by s square plus 4 into e power minus t. Okay, now as I told you, in the numerator, if you have two terms, divide each term. That is Laplace inverse of 3 divided by s square plus 4 minus Laplace inverse of s divided by s squared plus 4. 3 is a constant. I can take it out. If I take 3 out, I would have 1 divided by s square plus 4. I can write it as 3 square. So let me do that. Laplace inverse of 1 divided by s square plus 2 square minus Laplace inverse of s divided by s square plus 2 square. Okay, so now we have a direct formula, right? That is Laplace inverse of 1 divided by s square plus a square is sine a t divided by a, and Laplace inverse of s divided by s square plus a square is what? It is cos a t. Let me substitute these formulas now. That is, we would have here 3 into sine 2t divided by 2. Sine 2t divided by 2 minus cos 2 into t. Where should I substitute this now? I would have to substitute this value in this equation. Let me name this equation as, say, equation number 2. Okay, so let me take equation number 2. Yes, this is our equation number 2, correct? So now what should I do? This is our equation number 2. Now, what is Laplace inverse of 1 divided by s minus 1? It is, as I told you, it is e power a t. That is e power 1 into t. In place of a, I have here 1. So 1 into t would be e power t itself. And Laplace inverse of 2 minus s divided by s square plus 2s plus 5. We just found it using what? Shifting property, right? So we have missed one e power term here. That is e power minus t would come for each term. Okay, so that would be e power minus t over here, and finally it would come in our last step. So let me write that down. This would be 3 sine 2t divided by 2 minus cos 2t whole thing into e power minus t. Okay, so this is a Laplace inverse of the given question. So how do we find this? How do we solve this Laplace inverse problem? First we check for partial fraction formulas, and then we apply that formula. After that we take LCM. We'll find the constant values, that is ABC values, substitute them in the first equation, and then find the Laplace inverse. If we have a direct formula, we use the direct formula. If not, we use shifting property for inverse Laplace transform. Okay, so yes, that is it for today's class. Thank you.